Good day, everyone. So let us go now to the part two of our discussion with regard to transaction management. So for today's topic, we will be discussing about first is the locking and unlocking of tables. So when you say locking of tables, this will occur or this will happen the moment that a certain transaction is accessing a data in that particular table. And when that transaction is currently accessing that data, automatic, the table is being locked by that particular transaction so that no other transactions can access it and be able to perform changes of the data within it. When you say unlocking of tables, you are this occurs the moment that the transaction is completed or done with its changes in that particular table. So automatically when you say completed, the transaction has either committed or rolled back its action. Right? So once it's completed, automatically the transaction will release the lock of that particular table. Okay? So by definition, when you say lock tables, it explicitly acquires table locks for a current client session, and table locks can be acquired for base tables or views. When you say unlocking of tables, explicitly releases any table locks held by the current session, and lock tables implicitly releases any table locks held by current session before acquiring new locks. Now let's go to concurrency problem. When you say concurrency problem, this normally occurs the moment that there are multiple users who are trying to access the database at the same time. Because in reality, we know that there is no single user of a database. You always have a multi-user of your database. So just like for example, in your prisms, it doesn't mean that we only have one user for prisms. So imagine all the 15,000 students of USTP will access prisms at the same time, just like when checking for grades or enrolling online or viewing your COR. So do not expect that there will be one user at a time who will be accessing prisms. Instead, it will be multi-users accessing prisms at the same time. So these concurrency problems will then occur. So when you say concurrency problems, these problems or issues occurs the moment that there is a multiple concurrent access into the database. So there are different types of concurrency problems. First, let us discuss lost updates. So when you say lost updates, it normally occurs when two or more transactions select the same row and then update the row based on the value originally selected. So each transaction is unaware of another transaction. So the last update overrides the updates. So meaning if you have two transactions trying to access one data, the the last transaction to perform update on the same data will override the previous transactions update. So that overridden update is what we call the lost update. So let's have here a what they call this one. Let's have here the an example of what or how lost updates will occur. So in this case, you have here you wanted to update quantity on hand. So this is transaction one. We have the transactions and the computation per transaction. Okay, so for transaction 1, it will purchase new 100 units. So meaning nagpalit si company of 100 units. In transaction 2, the what they call this one, the company sell 30 units. So when you say purchase 100 units, you are going to increase the quantity on hand by 100. And when you say selling 30 units, you're going to sell 30, or you are going to deduct 30 units from your quantity on hand. So let's have here. So the correct result when you do the proper update, or the proper sequence of update per transaction. So in this case, this is an example of serialization. Okay. So meaning one transaction should finish uh, or should be completed before another transaction can access the same uh, data item. So in this case, transaction one, so this is the correct process. So transaction one at time one read the product quantity on hand to be 35 units. Since y- you purchased 100 units, so 35 plus 100, then the product quantity on hand will then be updated to 135. So once transaction 1 is terminated or has been completed, then transaction 2 can read product quantity on hand, which is now currently 135, and be able to the sell 30 units. So you're going to deduct 30 units from the product quantity on hand. So your cur- current product quantity on hand will now be 105. So this is how you implement correctly the date for the same data item. Now, let's have here an example of how this lost updates will occur. So in this case, as you can see, transactions were able to access the same data item at almost the same time, meaning there is no uh, transaction 1 is currently accessing product quantity on hand at the same time. Transaction 2 is also accessing product quantity on hand without yet completing transaction of the first transaction. So, 'di ba, when we say property of a transaction, it should be atomic, the atomicity, recall the acid, atomicity, and it should also be isolated. So, meaning that particular date, when you say isolated or isolation, current data item up that is being updated will not be available, or the update will not be available unless the transaction is being completed. But in here, in lost updates, transaction 1 is not yet completed. At the same time, transaction 2 was able to access the same data item. So in this case, in transaction 1 and transaction 2 both access product quantity on hand with the initial value 35. So given the 35, given the 35 value, then transaction 1 purchased 100 units, so added 100 units, and at the same time, transaction 2 sold 30 units. So what will happen? So 35 plus 100, since 100 man ang, so we have here now, when transaction 2 sold 30 units, it deducted the 30 units from the original value of product quantity on hand, which is 35, not the updated one, the one that has been added with 100 units. So that is why when transaction 2 has finished, it will give the stored value for product one or the value for product quantity on hand will be 5. So the 100 part here, the adding of 100 units is considered to be the lost update. This 135 part here. So that's how lost updates occur. Okay, so let's go to the second problem encountered with concurrent access to the database, and that is the uncommitted dependency. So this occurs when a second transaction selects a row that is being updated by another transaction. So the second transaction is reading the data that has not been committed yet and may be changed by the transaction updating the row. So this particular, when you say uncommitted dependency, it is what they call this one, violates also the isolation property of a transaction. So when you say uncommitted dependency or inconsistency problems, we have this what they call mm, we have two transactions accessing the same data item. Transaction one is trying to update the data item, and the uncommitted update has been accessed by transaction two. So that uncommitted update by transaction one can still be changed since it's uncommitted. So in the moment the transaction one will revert the what they call this one will revert the or will change the update for that particular data item, then transaction two will be seeing another value for that particular data item. So that's what we call inconsistency problems or uncommitted dependency. So let us illustrate here how this particular uh, problem occurs. So we have here uh, the same example. Transaction one will add 100 units to quantity on hand, and transaction two will deduct 30 units from quantity on hand. However, the end of transaction 1, instead of committing the 100 units na update, it has been rolled back. So, mubalik siya sa original niya nga or sa last committed transaction or last committed update. Okay. So, for the correct execution of this transaction, this is the correct one, huh? As you can see, transaction 1 is about to be completed first before transaction 2 will start. If, as you can see here, transaction 1 was able to read the current value for quantity on hand, which is 35. Then it added or it update it tries to update quantity on hand by adding 100 units that has been purchased. And then, so that will be 100 plus 35, that's 135 units. So instead of committing it, transaction one rolled back the update. So meaning the adding of 100 units was not saved permanently. Instead, the value for product quantity on hand was restored to its previous value, which is 35. So the moment transaction 1 completed its update by rolling back the update, then that's the time that transaction 2 can access data item, product quantity on hand. So at this time, still 35 and then minus 30 for selling of 30 units. Hence, the current quantity on hand will be equal to 5. So this is the correct way of implementing the update without uncommitted dependency. However, if you are going to check when when uncommitted dependency arises, let's have it here. So if you can see, if you can see here in the transaction side, you will notice that transaction 2 was able to access the update being made by transaction 1 that has not yet uh, been completed. So it's uncommitted. So at this point, the moment that the update adds 100 units to the 35 quantity on hand value, then automatically or this at this same point of time, transaction 2 was able to read the uncommitted changes, which is 135. Then from that 135, the sold 30 units were deducted. However, after it has been deducted, transaction 1 rolls back its changes or its update. So dapat mabalik siya 35. However, na-access naman daan ni transaction 2 ang uncommitted changes. Munang, ang iyahang display nga balance is 105. So that is deducting the 30 units from the uncommitted changes. So this is how uncommitted dependencies or arises. Okay. Now let's go to the third problem, which is what we call inconsistent retrievals. So this occurs when a second transaction accesses the same row several times and read different data each time. So this is also similar or very similar to uncommitted dependency. It's just that um, the second transaction tries to access the same data multiple times, but it's giving out different values each time it tries to access the same data. So let's have here an example. You are going let's try to demonstrate here retrieval during update for inconsistent retrievals. So the transaction 1 is select sum, meaning it will give the total product quantity on hand from the product table. At the same time, transaction 2 is trying to update quantity on hand for the particular product code by adding 10 and deducting 10 for two different product codes and then before it commits. So for it to be corrected, it should be that this one. For product code, it should be 15 plus 25. As you can see here, 1546 QQ2 should be added by 10. 156 QQ2 should be added by 10. So it should give the product quantity for this to be 25 added by 10 man. And for the product 1558 QW1 is deducted by 10. So it should be 23 minus 10. So that's 13. So this is how it looks. However, when you do inconsistent retrievals, ang mahitabo like this. So nag-access transaction 1 accesses a different product for initial value of quantity in hand to be 8. So 8 na siya. Then another product na po, the same transaction, iyahang gi-read ang quantity on hand. So 8 plus 32, 40 na atong quantity on hand. Now here comes transaction 2 nga mag-add siya og 10 nga values sa isa ka particular nga product code which is QQ2. So plus 10. So So nakadiri 15. So while you are doing so 15 initially, so na siya 25. So dapat naa kay pila man 40 plus 25. However, before pa nag 40 plus 25 dapat 65. However, before pa unsay tawag ani na commit ang changes, gi-read na po siya ni transaction 1. Ang iyahang na-read is ang 25 nga update. Okay? It's the 25 nga update. So it's expected that when transaction 1 was able to read the update that has not yet been committed by transaction 2, so 25 plus 40 it should be 65. And then at the same time, transaction 1 read the product quantity which is for QW1 which is 23, then it should be giving you 88. However, as you can see, transaction 2 also read QW1 to be 23. So wala niya na nakikita pong 88. Then gilessing og 10 which is 13. After doing that, ay siya nag-commit. So ang hitabo diri unsay what will happen 88, and then si transaction dapat kuan man gud ang nahitabo dayon diri nag-access na pod og laing quantity product si transaction 1, pero ang iyahang basis kay katupang dinhi kato naka-reach og 23, wala niya ni nabasa, mo nang na siya total nga 96. 88 plus 8, that's 96. And then nag-read na po siya another 96 plus 6 nga product quantity nahimo 102. So man siyang inconsistent retrievals. So lain-lain ang mahimong total sa product quantity on hand when transaction is accessing the uncommitted changes of another transaction. So that's how inconsistent retrievals occurs. Okay, so let's go to the scheduler. So in order for these transactions not to encounter concurrency problems, then there is one responsible in scheduling all of these transactions as to when they can access each data item. So we call it the scheduler. So this scheduler is the one who is responsible in scheduling the different transaction who is trying to access the database at the same time. So this will be the one who will make sure, or the scheduler is the one who will make sure that no transaction is accessing the same what do you call this one, the same data item without completing uh one transaction first. Okay, so it is the responsibility of the scheduler that will make sure that when a transaction is being executed in an interleaving way, there will be an insurance that serializability and isolation of each transaction will also be implemented. And it is also the scheduler who is responsible as to the order of transactions to be processed. So usually first come first serve. Who requested first for that particular data item will be entertained first and should complete the transaction before another transaction can access the same data item. So let's talk about serializability of schedules. So when you say a serializable schedule, It is a schedule of transactions operations that is, when executed in an interleaved way or an interleaved fashion, it will give you the same result if you are going to execute it in a serial order. When you say serial order sequence, 1, 2, 3, 4. Pag mo pag interleaved way, pwede nga 1, 3, 4, 2. But your result from 1, 3, 4, 2, that is the interleaved way, should be the same with the result that you will generate when you execute the transaction in a serial order. Itong 1, 2, 3, 4. So if you will have the same result, then that's the time that we know that your schedule is serializable or your transaction is serializable. Okay. So let's go now with concurrency control with locking mechanism or with locking methods. So when you say locking methods, it's granting lock to tables to or locking a table to a specific transaction or for a specific transaction. So your lock guarantees an exclusive use of that data for that particular transaction. So the transaction will acquire lock or locks prior to data access. So who will process the locking of transaction? It's what we call the lock manager. So it is the responsibility of the lock manager to check if that particular data is not being used by other transaction or is available. So if available see that particular data, then the lock will be granted to the requesting transaction. However, if that particular data is not available, then the lock will not be granted to the requesting transaction. Instead, the transaction who is requesting for an access or for a lock for that data will wait for that particular item to be released by the previous transaction who is currently handling it. So when we say locking methods, we have different lock granularity. When you say lock granularity, how big is the scope of the lock? So when you say database lock, meaning one transaction will lock the entire database. So no other transactions can access the database unless it is being or unless the current transaction is completed. So that's very unrealistic because we know that we have multiple users in a database who will try to access the database at the same time. So that's not too idealistic or realistic. And then we also have what we call the table lock. So when you say table lock, the table who holds that particular data will only be locked. So example, if you are going to access the student student address, then the student table will be locked exclusively for that particular transaction. So that's table. Still, it's not uh, ideal because you know that there are instances that you need to request multiple tables para na kay ma-perform nga update. Or there are multiple users accessing the same table. So it's not still ideal. We also have here the page lock. So when you say page lock, it's the page from the what they call this one loaded in the memory. So kung unsa lang tong na-load sa memory nga page part nga part sa database, mao to ang kuan. Mao to ang iharap mong i-lock. When you say row lock, only that particular row in a table will be locked, or we call it the uh, attribute lock or field lock. Ito pong column iya i-lock. But in reality, It's combination of page, row, and field log. Okay, so here's the discussion for this. All right. So you also have, so that's for the clock granularity. So that's for the part two. That's the end of our part two for transaction management. Then we'll have a quiz, particular for part two. After that, we'll continue with part three.